Hey guys, Mike here from Applied Engineering and Design, and I've got a brand new tutorial for you here with this fancy wrench that I designed. So what we're going to do is I've got this that I just whipped up here in Rhino, basically a wrench with a 1-inch hex on the end here. Works just like a box wrench, closed end, 6-sided here. Just something quick I wanted to showcase a little bit so we can do take a little aspects from our whole feature video and a little bit from our flip milling video, and we can kind of just make this part. So let's get started. The first thing we're going to do, as with everything, is check. We're going to go in here. We don't need 4th axis for this one. I'm just going to go ahead and shut it off so it doesn't output the code for that. We're going to go ahead and set our stock. First thing we need to do is to set our stock here. And what we're going to do, if we do copy model bounding box, it shows that it's a 1/4 inch high, which is fine. We're going to pretend we're working with a piece of, 1/4 inch steel. And it looks like it's setting the size to about just over 6 1/8 and just over 1.5 inches wide. So for all intensive purposes, that's not the size you would get it. So what we're going to do is, let's say we cut this piece from 1 3/4 stock like that. And we're going to go ahead and hit OK. And if I turn on my stock, we can kind of see that it's larger than the shape of the model. So now we're going to set up our zeros and everything. So our first setup here, we're just going to call this op1, and I just double click on that to change it. So we're going to do our setup, and we're going to set up our axes here. And the default setup right now works pretty good, so we're going to hit OK. Oh, actually, we don't need a second setup. Let's delete that. So we're going to align, first we're going to align our stock. We just want it to be centered in our stock. The Z alignment can be center. It doesn't matter. It's the same height right now, but we're going to center it so there's a little bit of stock on all sides of the part. Let's hit OK. So now we look at it and we got a little bit of room everywhere. Cool. So what we're going to do is, actually what I'm going to do is change it, because as looking in real close here, if we were to bring a tool in along the edge here, and let's say this was just sitting in a vise on parallels, it's going to hit the side of the vise, especially since we're going to machine it down. We don't want it to hit anything. And there's 2 ways we can machine this, and I'm going to show you both ways in this video as well. So let's go back and we can just double click on stock, and I'm going to go ahead and make this 2 inches. We'll just make it 2.5. Hit OK. We're going to realign our stock. Hit OK. And now look, we got all kinds of room there. So cool. What we're going to do is we're going to set our 0 point to this top left corner, which we're going to pretend this is sitting in a nice vise on our CNC. So we're going to set our world coordinate, and we're going to pick set to stock box. And if we look, it generates an arrow right up at this upper left corner, which is going to be highest Z, which means we'll touch off the top, and northwest position, so that's perfect. We're going to hit OK. And it moves it and brings it down exactly where we're going to want it here. Cool. So next what we're going to do is, let's go ahead and add a work 0 also. That way we can have it, make sure it sets out a G54 in there. And we're going to do stock box, highest Z, northwest as well on that, and generate. And that creates this nice work 0 right there. So the first thing we're going to do is, let's go ahead and take care of some of these holes in here. And I know, since I designed it, that these bigger holes are 1/2 inch, and these little guys are 3/16. So what we're going to do first is, let's drill the 2 3/16 holes. So let's come down here in our tool browser, and we're just going to create the tool right away. We'll go up to drill. I'm going to change the name to 3/16 drill. Change our diameter to 1875. And flute length and everything we can just leave alone for right now. I like to copy the name into the comments, so it'll output it in the post. We're going to change this to flood coolant, and we're going to leave it as tool number 1. Feeds and speeds, let's do our load from file. So let's say we're making this out of, we would probably make this out of tool steel, but we're going to go ahead and just do it out of like 1010 or something kind of mild steel for now. We're going to lower all this down to like 2,000 feet per tooth. And we're going to do save as new tool. Hit OK. All right, so we got that drill we're going to do. So as if you watched our last video was on hole feature machining. So we're going to go ahead and use hole feature machining to take care of all the holes here. So if we head over here to features, and we can see that there's no hole features, and we're going to select a filter here, and we're going to use a diameter filter this time. We didn't actually use it last time, so I'm going to say our minimum diameter can be 0, but let's say our max is going to be 0.25. So that means it should only select the 2 3/16 holes. And we're going to hit OK. We're going to come in here and do create hole features. I'll give it a minute to pop up. Oh, I'm sorry, we need to select the object. And hit OK, or right click as I did. And you can see it created these 2 hole features, and it picked the 2 right ones. And I didn't have to go click them, I didn't have to do each one. If we tick down, we can see there's instance 1 and instance 2. Great. What we're going to do is now we can create our hole feature machining operations. And that brings up this little dialog box. What we're going to do for these, we're just going to do standard drill. I'm going to drag it over. And we're going to set our top Z, which will be 0, and our bottom Z is minus 0.25. It selected everything already. So let's do create hole feature mop set. If we take a look at the hole feature 1 that it created here, it created a standard drill as an operation, and you can see that it created drill 1. We already had created a 3/16 drill right in the beginning, so we're going to go ahead and change that out by double clicking on standard drill. Coming up into tool, selecting 3/16 drill. Feeds and speeds, we're going to load from the tool, which was everything we set earlier. Clearance plane looks good. Cut parameters. So now the drill depth, all we're going to change here is we're going to add the tooltip to drill depth. That way we get a nice clean hole through. And sorting we can leave alone. So if we do generate, you can see it created exactly what we want, and you can see underneath it poking right through. So if we go ahead and we simulate it, you can see it just drills the 2 holes all the way through out of our plate. So that's going to be the first thing we're going to do. Next, what we're going to do is we're going to do these other holes as well. So we're going to do the exact same thing. I'm actually going to come down here and I can delete that other drill. This time we'll let it create its own tool, and we'll just edit it after the fact. Let's go back to features. Let's change our filters. Now we're going to set our diameter filter. We want it to be a minimum of 0.25 or 1/4 inch. And our maximum, we can leave that alone. So we hit OK. So now it should pick these 6 holes, 6 1/2-inch holes. And if we hit that and we select the top surface, right click. Oh, I hit the wrong one. Select the object. Oops. There we go. If we select the object first and hit create hole features, there we go. Now we can see that it selected the 6 large holes right there and created it as another hole feature instance. And just for sanity purposes, we're going to do 3/16 holes. And we're going to set this to 1/2-inch holes. Cool. So now we're going to do the same thing. We're going to click on it. We're going to do create hole feature machining operation. And now what we're going to do is we are going to, why don't we hole pocket them? Instead of hole profile, we'll just pocket them right out. Drag that over. Going to add a flat mill. And we can see all of our settings the same. Create hole feature machining operation. Now it came over and it named it half holes, which is what we named our feature down here. And if we tick that down, we can see hole pocketing. And if we come over to tools, we see there's a flat mill now. Let's double click and go into the flat mill. And let's say we're going to do it with a 1/4 inch end mill. Set our diameter. It's probably only going to be a short little tool. There we go. Tool number 2. Say it's a 2-fluter, flood, coolant, feeds and speeds, load from file. Change this to 2 thou again. Make sure this is set to 1/4 inch. And leave everything, hit OK, save as new tool. Hit OK. And we're going to, actually I should have edited it, but so we're going to end up doing the same thing. Double click hole pocketing, tool, choose 1/4 inch end mill, feeds and speeds, load from tool. Clearance plane looks fine. Cut parameters. We're going to check this box here that says determine using 3D model. And that'll tell us, that'll detect the depth. And the arcs use arc diameter is already in there as well. So we're going to leave everything else alone for now. Same in here for entry exit. And we're going to go ahead and hit generate. And as you can see, cleans it up right at the bottom there. And let's say we don't want to leave a burr on that edge and we want to go a little bit deeper. We can come back in, cut parameters, turn this back off, and let's say we're just going to go down an extra 50 thou. So we set that to 300. And we can see it pokes out the bottom just a little bit. Perfect. Cool, now we can come delete this flat mill here. Now if we simulate that, exactly what we want it to look like. Cool. So now we want to take care of this hex shape here. What we're going to do is we're going to set up pocketing, do 2-axis pocketing. And for our regions here, we're going to select drive containment region. I'm going to go ahead and just select the 6 sides of the hexagon here and right click. For tool, let's rough it out with that same 1/4 inch end mill. Cut parameters. We're going to leave 5 thousandths of stock so we can come in with like an 1/8 inch and clean it up. And so location of cut geometry, we can see it's at the top. Our depth is, I'll show you using this little arrow here. We can hit this arrow. We can check that corner and that corner, and it's automatically going to select 1/4 inch, which is nice. If you have a solid model, you can just pick your depth right there. And I think what we're going to do, let's do 50 thou per cut, per step down. We're going to helix into it as well. And here's the cool feature. We're going to check apply entry exit at all cut levers, so helix is in each time. And under advanced cut parameters, we're going to turn on arc fitting, 2/1000 fitting tolerance, and use smooth cut connectors. We're going to jump back over to clearance plane. What we're going to do is we're going to set our cut transfer method. So since we know it's going to be working on this for this whole machining operation, we're going to set our skim clearance to 20 thousandths, which means instead of pulling all the way back up to the main clearance plane way up here, between each step down, it's only going to pull back up 20 thou. And we'll see that in the operation here. You can see it doesn't pull all the way back up. So now if we simulate this, we can take a look at what it leaves us. And that's looking pretty good. And again, just like the other holes, let's go back in and we're going to set our cut level to 300 so that there's no burrs. And regenerate. So we're good. All right, so the last thing we're going to do for the hex is we're going to add a profiling. And we're just going to choose the same 6 sides of the hex. Now for tool, we're going to create a new tool. Create an 1/8 inch end mill. We'll leave everything else, just change the name over here. Change it to tool 3. And make sure we change it in here as well. And my machine maxed out at 12,000, so we're going to set that guy to 12. Hit OK. Save as new tool. OK. Feeds and speeds, load from tool. Clearance plane. Looks good. Cut parameters. Now what I'm going to do is, let's say I want to make it slightly bigger, because if it's going to fit around a 1-inch hex, maybe we want 5 thousandths of clearance. So I'm actually going to set a negative number here. The -5 thou, which should expand it a little bit into the surface there. And we're going to check this box. Use outside, inside for closed curves. And we're going to do the inside. And cut levels is at the top again. And we know we want to do 300. We can do it all in one step because we're just going to profile the edge. And we're going to do 2D entry. And this is a little small, but we're going to take a look at it, see how it looks first. Turn on our arc fitting and smooth cut connectors. Hit generate. So now let's take a look at our tool here. And our path, this arc comes right into this corner here. We definitely don't want to do that. So a little trick here we're going to do is we can't do curve seam on it. If I go run curve seam, it says select a closed curve. So what we're going to do is, I'll show you a little trick, is we're going to run dupe edge. And I'm going to go ahead and choose the exact same 6 segments, right? And I'm going to go ahead into my reference layer, right click. And I'll hit join. So that made a single closed curve now. If I turn this off, you can see my closed curve right at the top. So now if we go back into profiling, remove all that, select drive containment. Now we're going to select that curve I just created and generate. So now the curve has what we call a seam at this point here. Still looks bad going right into the corner. So now what I can do is now I can run curve seam. And we're going to select that curve and right click. So now there's a little arrow right here. And I can move around and select this point. So what we're going to do is we're just going to drag it till we get to this midpoint on the bottom. Right click. We right click and regenerate. There we go. Now we got a nice radius into the corner, a nice radius back out. Exactly what we want. Now if we simulate that, just like that. So the reason it looks like that is we'll go back and we'll rerun this one. After we changed the depth to 300, we didn't rerun the simulation. Okay, and now we'll run the profile again. And there we go. Looks nice. Now that we have all our inside features of this, we can work on the outside. So I think what we'll do is we'll do the exact same thing. We'll create this curve. And because there's not really, this is essentially a 2D model, we're doing everything 2D. But I think this is fairly typical of what you would be working on if you had a job for a cam or needed to make tools. You know, a lot of people just make their own tools as they need them. We do that as well. So what we're going to do is now we're going to profile this edge. And so the first thing we're going to do is, let's say we're going to drop it right out. And so I'm going to run dupe edge again. And I'm going to go ahead and select this entire outside edge. All right. And then join. So now we got a single curve around that top edge there. So just like everything else, we're going to do profiling. We got that. It's already pre-selected. We're going to do our 1/4 inch end mill. Our cut parameters are going to be, we're going to do use outside inside and select outside this time. And our cut levels, our total cut depth is going to be 300. And what we're going to do is I want that last finish depth to be very, very thin. So what I did was I set our rough depth to go, and that should leave it 10 thou there, and then it'll finish off with that final pass to drop it out of there. So let's go to entry exit. Now this time what I want to do is we're going to do a long path 3D entry, which means it's going to ramp it down into it. And we're going to do that apply entry exit level at each cut. And advanced cut parameters, we're going to perform arc fitting, so it makes a nice arc around the two outside edges here. Turn on smooth cut connectors and hit generate. And you can see what it does is it's going to come in and ramp. That doesn't look right. It's at the very bottom there. So let's go back in and take a look at what happened. Yeah, everything is set to the top. And if I turn off that is set. Oh, I'm sorry, I see what I did. I left my rough depth cut at the full 240 thou. So what we want to do is lower this down, way down, so we're doing about 48 thou per cut. Hit generate, there we go. Now that looks right. So what it's going to do is cut all the way down until we get to the bottom and do that last final cut. So let's simulate this. You see that exit here? We lucked out. That's not going to hit the vise because we picked all that extra material there. But I'll show you a trick to fix that. Like, let's say we didn't want this to come out like that. So, and we don't want this to ram into there. So that's a couple things we want to change. That's why the simulation is so great. So if we go back in, let's go to our entry exit. And what we're going to do is we're going to change our entry exit to linear. And the trick here is to set this angle to 0, which will be right along the tangent. And we can set this a little smaller to 0.125. And we're going to turn this on the clearance plane. We're going to turn the skim clearance back off to go to the full clearance plane. You can see it's going to zip back up and go over. Let's watch the simulation real quick. Speed it up. And you can see it's ramping down each one. And it does go up to the clearance plane, but it's not going to hit anything. So cool. So that, if we were done, that's cool. This would allow us to let it drop out like this. Now let's say we wanted to machine both sides still, but we needed a way to locate. Can actually use this edge here. What we would do is, let's change this now to our cut levels. Our total cut depth is going to be half the depth. We do it all in a rough. Generate. And if we look at the simulation now, it'll go down about halfway and leave it like that. So now we would want to flip it. What we're going to do is we're just going to create op2, do setup, CSYS, and I'm going to go underneath and hit select surface. And I'm going to select this bottom surface And you can see it changed the arrows to that. So now what we're looking at here is everything is kind of flipped. But our Y is the same. So what we're going to want to do is sort of take a look at underneath how we're going to use this exact same corner. That way, you know, we want to touch off this exact same spot so that everything lines up right and everything is good from there. So if we're going to flip it, let's say we flip it this way, 180 degrees. So this is now down here. We're actually going to want our Y to be facing down, opposite of the way it is before. So we're going to rotate around Z till we get there. And so now, if I turn it around, that's how it's going to look. That's the side we're going to work on. Cool. So we hit OK. Change this to Op 2. What I'm going to do is I'm going to take this, I'm going to Control C, Control V, bring it down here. Now, if all I do is regenerate, it thinks that's the top still. We're going to go in, change our cut levels to do at bottom, hit OK. And now if we simulate, there we go. Watch that again. Yeah, so we don't want it to do that. What happened was, by doing at bottom, we actually want to move that piece up. But without doing any more work in the Rhino, we can do it right with the RhinoCAM. Cut levels, we can do pick top. And I'm going to hit this little arrow. I'm going to just choose a point that's on top. So now that set that top there, and because we want to make sure it cuts all the way through, we're going to do like 175 to generate. Now it's doing it correct, and you can watch it. There we go. As simple as that. We just made a wrench in 2 different ways to do it. Now I drilled those 3/16 holes here because that would allow us to actually bolt it down to something if we needed to work off a plate, which is nice. We could take a plate like this. Let's say we didn't have enough room, or we wanted a plate that was very, very close like that. If our stock was close, we could then do all our hole work in a vise, make a whole bunch of plates like that, then bolt it down to like a piece of Mic 6 or some fixture plate, and then do all our cutout all the way in one step. And that way that would be pretty accurate as well, and we'd be locating now off those 2 pins, which would be easy to set up in here. Just change our 0 or work 0 to the center of one of those pins. So quick and dirty little making a wrench here. Make sure you guys subscribe to our YouTube channel, follow us on Twitter, Applied ENG Design, and look out for some cool new videos. We're going to be doing some 3D printing stuff coming up with 3D Printing Day in December. So hopefully I can get some more 3D printing videos on here. But as always, we're going to be doing the RhinoCAM series, with all kinds of videos, even just little tutorials like this. So if you guys have any ideas for projects, shoot us a message on YouTube or email us, info@appliedengdesign.com. Once again, take care.